Hi, this is Evans from Crazy Chemistry, and today we will speak about europium. Imagine waking up and everything is black and white. There is no colors, no red, no blue, no brightness, all because of the lack of one element, europium. In this episode, we will explore why europium is responsible for the colors in your screen, how it produces red and blue light, and why it is one of the most important elements of modern display technology. Europium powers what you see. Without europium, modern display technology wouldn't exist. Europium is element number 63 in the periodic table. It is a soft silvery metal in the lanthanide series. Its atomic mass is 151.96 U. Its atomic radius is 180 picometers and its melting point is 822 degrees Celsius. It is one of the most reactive rare earth elements as it reacts with atmospheric oxygen very fast. Like other rare earth elements, it is found embedded in minerals such as basnasite and monazite, and it can mainly be mined in China, US, and Australia. Its most common oxide form is europium oxide and looks like this. What makes europium so special is its electron configuration, which looks like this. Europium can sustain two oxidation states, europium 2 plus and europium 3 plus, and their electron configurations look like this. Since the 4f orbital can accommodate up to 14 electrons, europium 2 plus, which has an electron configuration like this, has its 4f orbital half filled, which is a very stable configuration. That's why, unlike most lanthanides, europium prefers the plus 2 oxidation state over the plus 3 oxidation state. And this is where things get interesting. Europium can produce light, and not just any light, very pure and intense colors. But let's understand how light is produced. So initially, europium absorbs energy through electricity or radiation or any. This energy is absorbed by the electrons of the europium atom, and these electrons get excited. When they get excited from a low energy level, they get some energy and they go to a higher energy level state, and then because this state is very unstable, they drop down again back to its original place. When the electron drops from an excited state down to its ground state, then the extra energy that it loses, it produced as a photon, which is light. This process is called luminescence, and we will discuss in more detail in a different video. Europium can produce two different color lights based on its oxidation state. Europium 3 plus produces red light and europium 2 plus produces blue light. This is happening because of how electrons move inside the atom. In the case of europium 3 plus, the light is coming from transitions inside the 4f orbital. And these transitions are called 4f to 4f transitions. They produce sharp red light with a wavelength of 610 to 630 nanometers. But in the case of europium 2 plus, something else happens. When the electron gets excited, it jumps from the 4f to the next energy level, 5d, as there are no low energy empty 4f states available in the 4f orbital. This is a 4f to 5d transition. The energy difference between the 5d and the ground state of the electron is greater, and therefore the photon produced has more energy and produces this blue light with a wavelength around 450 nanometers. So one element europium having two different states can produce two different color lights. That is why europium is used for high quality displays. Without it, every color would be very dull. So cerium that we saw can sustain two oxidation states, which is useful for catalysis, Samarium can sustain 2 oxidation states, which is useful for its magnetism, and then europium can sustain 2 oxidation states, which is useful for producing light. Europium has also a nuclear property. Certain isotopes of europium can absorb neutrons. That's why it can be used as nuclear control material. In terms of price, europium is one of the most expensive rare earth elements, with its price ranging between $30 to $200 per kilo because it is in high demand. So the next time that you look at your phone or the TV or your screen, remember that these colors are possible because of europium, the element that you don't see but makes everything visible. So that's it for today. Thank you for watching the video. If you like the video, please consider liking, subscribing and sharing. Leave a comment if you like. I'll see you next time. Bye.